In this clip, we will study second-degree polynomial equations of quadratic form using a geometric numerical method for finding the solution. This is the general form of the quadratic equation. Y is equal to ax squared plus bx plus c. We want to compute the roots, so we're going to set that equal to 0. Now the first thing we're going to do is divide through by a, this by a, and this by a. So when I divide this term, I get x squared. When I divide c, I get c over a. And when I divide this term, which I'm going to transpose over to the other side, it'll come out to plus b over a x. And when I transpose it, it becomes minus b over ax. Then I'm going to construct a geometric diagram, this rectangle here. And I'm going to assign this length to be minus b over a. And this width to be x. So when I multiply that times that, it has to be equal to these two areas. One area is x squared, that term, and the other area is c over a, that term. Now we're going to make an assumption that we know is false. We're going to assume that every quadratic equation is a trinomial square. All right, that's going to produce an error. The deviation from a trinomial square, I call it e squared, the deviation, the absolute value, will be greater than or equal to 0. We can compute this deviation from a trinomial square. I don't show it here, but I show the result. This deviation from a trinomial square is equal to minus b divided by 2 squared minus a times c, where these coefficients are the only thing that we have to be concerned about. So we can compute it, and then we can find the roots. It's going to be minus b divided by 2 plus or minus the square root of the deviation from a trinomial square, and then both of these terms are divided by a. We can also, by this method, find the vertex. All quadratic equations plot as a parabola, and the vertex is going to be the xy coordinate at the lowest point or the highest point, depending on the orientation. Consequently, the vertex will be the same as this, minus b over 2 divided by 2 divided by a, and then it'll be minus the deviation from a trinomial square divided by a. So this will be the x coordinate and the y coordinate at the vertex. And we can get it using this geometric numerical method. The first quadratic equation that we're going to solve, 3x squared minus 18x plus 10, I'm going to set it equal to 0. We want to compute the roots. And I'm going to do it using only arithmetic first, and then we'll use, and making one assumption, that it is a trinomial square. And we'll compute the deviation from a trinomial square. The first thing I'm going to do is divide everything by 3. That x squared, divide that, I get a minus 6, which I'm going to transpose immediately over to this side, becomes a plus 6. And then divide this by 3 and I get 10/3. 10 divided by 3. Here's the geometric diagram. I'm going to make this length there 6. That length is 6. And that length, the width of the rectangle is going to be x. So 6 times x is equal to this area plus this area. This area, we're going to depict each term as an area. All right. Now here's my assumption. If this is a trinomial square, then that area will be equal to that area. And the root of a trinomial square will be 1/2 of this, 6. So there it is. X is equal to 6 divided by 2. I get a 3. Now I'm going to put it into the equation to see if it balances. So I have 3 squared there. I have 10 over 3 here, plus 10 over 3. Is that equal to 6 times 3? No, it's not. This is 18. That's a 9, and this is 3 1/3. That's 12 1/3, and that's not equal to 18. So I'm going to compute the deviation. 18, 6 times 3. 3 squared is 9, and I'm going to transpose it so it becomes a minus. 10/3 I'm going to transpose, and that becomes a minus. When I do the math here, I get the deviation from a trinomial square to be 17 divided by 3. All right, so the roots will be 3, and then if it were a trinomial square, it would be just 3. But here's the deviation, plus or minus the square root of this deviation. Square root of 17 over 3. In algebra, we have to get rid of radicals in the denominator. So I'm going to multiply by 1. Square root of 3 over 3 is 1. 3 times 17 is 51, so that's a square root of 51. Square root of 3 times square root of 3 is 3. So here's the roots. 3 plus or minus the square root of 51 divided by 3. And we got it doing only arithmetic. We made the assumption that this was a trinomial square. Turns out it isn't. If it was, that would be a 3. The root would be just 3. Here's the deviation. Square root of 51 over 3. This is the same equation that we just did, using only arithmetic to find the roots. We're going to use the geometric numerical method to not only find the roots, but also the vertex. So the first thing we want to do is identify the constants. This coefficient is plus 3. A is 3. B is minus 18. C is plus 10. The deviation from a trinomial square is minus b over 2 in these two places. We're going to use a determinant to facilitate the computation. So b minus 18, and this minus times that minus is going to make this a plus. So 18 divided by 2 is 9, plus 9. And I'll put the 9 there. And then this A is going to be put here, 3, and C is 10. So I multiply this diagonal, 9 times 9, I get 81. Then I must subtract the other cofactor, this one. 3 times 10 is 30. When I do this subtraction, I get 51. So the deviation that this equation has from a trinomial square is 51. So what are the roots? X equals this 9 divided by A by that 3, 9 over 3, plus or minus the square root of the deviation, 51, divided by a. When I do this division, I get 3 plus or minus the square root of 51 over 3, which is what we got in the last slide using arithmetic. The vertex, this 3, this is the x coordinate at the vertex. That's the lowest point or the highest point, depending on how the parabola is oriented. The vertex is 3, x coordinate. The y coordinate is minus the deviation, minus 51 divided by 3. When I do this division, I get 3 minus 17. So there's the vertex, 3, comma, minus 17, x and y coordinate. And this will give us the roots. 51 is approximately 7, the square root. So it's 9/3 plus or minus 7/3. And when you do it, you'll get a number here slightly above 0. In fact, it'll be approximately 2/3. And when you add this 7 to 9, you get 16/3. So this is going to be about 5, 0. But all I did was 6 easy arithmetic steps. I divided 18 by 2, that's 1. Get that 9. I multiplied this, that's 2. I multiplied this, that's 3. I did that subtraction, that's 4. Then I can write down what the roots are. I did this division, that's 5. I did this division, that's 6. So I only had to do 6 arithmetic operations to get the roots and the vertex. In the quadratic formula, putting those in the formula, I had to do 9 to get the roots alone. So this method lends itself to graphing quadratic equations. In this clip, we have a problem: acid rain, lake pollution, and the antacid required to neutralize the pollution is given by the equation, this equation, pollutant, and this is the antacid there. Anyway, it's a quadratic equation where A is the antacid in pounds per cubic yard of water, and P is the pollutant. And we want to find out how many pounds of antacid will be needed to neutralize the pollutant. So my coefficients are 1, minus 6, and plus 9. The first calculation, this is minus b over 2, so that minus and this minus is going to flip this sign to a plus. 6 divided by 2 is 3. Now I'm going to put it there and there. This coefficient 1, it goes here, a, and this constant 9 goes there. So then I could calculate the deviation from a trinomial square. I get 3 times 3 is 9, and then minus this cofactor. 1 times 9 is 9, and when I do the subtraction, I get a 0. That means the equation is a trinomial square. What it means, if you plot it, it'll come down, it'll touch the x-axis just once. The roots are redundant. It's 3 plus or minus 0, and then it starts up again. So e squared is 0. The roots are a is equal to 3 plus or minus 0, or just 3, 0. And the vertex is also going to be 3, 0. That's the low point. What this tells us, the vertex now, 3 pounds of antacid per cubic yard of water is needed to neutralize the pollutant.